Welcome to math class, everyone. This video is for chapter 10, lesson 6, finding cross sections of three-dimensional figures. And here on this first slide to start your video, I have a bunch of different examples that you can look through to kind of get an understanding of what we might be talking about. Your learning target is to be able to describe the cross sections of a solid, whether you cut vertically, horizontally, or diagonally. For certain three-dimensional shapes, the cross-section that you take out will vary. You'll know that you can do this if you can explain the meaning of what a cross-section is, describe the cross-sections of prisms and pyramids, and be able to describe the cross-sections of cylinders and cones. So to get you started here, consider a plane slicing through a solid. A plane is just a two-dimensional shape that goes on and on in all directions forever. If you think of like a big stack of paper, your plane would be just one sheet of paper. So imagine then that you're taking one sheet of paper out. That's kind of going to be your cross section. For example, the diagram shows that the intersection of the plane and the rectangular prism is a rectangle. So again, if you're thinking of a big book and you just rip out one page from the book, that's your cross section. Your cross section would be a rectangle. So for example, 1A and B, we're going to describe the intersection of a plane and the solid shape. For A, it is a rectangular pyramid. Our cross section in tan or orange, you can see slicing through it. So we'd say the diagram shows the intersection of a plane and a rectangular pyramid. We would also say the intersection or the cross section is a rectangle. And this would be the cross-section piece that we pull out. That'd be like the little slice or the sheet of paper that we pull out from there. For B, this diagram shows a rectangular prism. The cross-section, you have to imagine, is kind of cut at a diagonal from the center towards that bottom vertex. The intersection is a triangle, and I'll outline the shape. Now you give it a try. Please describe the intersection of the plane and the solid, and then push play when you're ready to continue. So for one, the tan cross-section, or the tan plane, is going straight down through the right side or the right face of this pyramid, and the shape that we're left with, in this case, is actually a trapezoid. In example number 2, or try it number 2, we have a triangular prism, and that one is being sliced or intersected right down through the middle. And so for this one, our cross section is going to be just a perfect triangle. In example 2, we're now describing cross sections of cylinders and cones. And you can see the orange cross section here going straight through the cylinder. That is going to give you a cross section that is a circle in the exact same shape and dimensions as your base. And for B, now we have a cone, and that cross section is being taken straight vertically through the height. And so you can see this one is going to give you a cross section that is a triangle. And in this case, the triangle is basically going to be the dimension of your circle's diameter, and the height of the triangle is going to be the same as the height of the cone. Now you pause and try it. Describe the intersection of the plane for the cylinder and for the cone. So for the cross section of the cylinder, we're going to end up with a cross section in the shape of a rectangle. And for the cone, we are going to have a cross section in the shape of a circle. Example number 3 is modeling real life. An ice sculptor cuts the block of ice into 3 identical pieces. What is the percent of increase in the surface area of the ice? So let's start by just finding the lateral surface areas of the rectangular prism. Let's start with the left and the right side. It's 1 by 1, so that's 1 foot squared plus 1 foot squared. So we have a total of 2 feet squared. Now let's find the top and the bottom. That's going to be 3 by 1, so that's 3 feet squared plus 3 feet squared. That's 6 feet squared additional. And then the front and the back is also going to be 3 times 1 is 3 feet squared. So that's another 6 feet squared. So altogether, 6 and 6 is 12, and 2 more, that is 14 square feet. And that's for the original. Now if we cut this up into 3 identical pieces, we're essentially now going to have a cube. And for this cube, it's going to be 1 foot by 1 foot by 1 foot. We know that a cube has 6 faces, and each face is going to be 1 times 1. So that's 1 foot squared times 6, and that's 6 feet squared. That is the area, the surface area of just 1 cube. It says we cut it into 3 identical pieces, so we end up with 18 feet squared. And finally, what is the percent increase? 18 divided by 14 is 1.285, so we'll say 1.29, which would be 129%.